Friends, today we'll study hardness of material. Now, for studying that, we should know what is hardness. Now, hardness is defined as the resistance of a material to permanent or a plastic deformation of its surface by indentation under static or a dynamic load. Then we will see why the hardness are measured. From the hardness measurement, we can determine the tensile and the compressive flow curve of a ductile material up to a certain plasticity if that ductile material does not show any high deformation. So that is the use of hardness. Now hardness test is carried out for every and each and every material that is that is being produced in the industry. So we have to do the hardness test for every material. Now there are types of material. There is hardness test. Now you can see according to the test is conducted, they can be classified as first one is the indentation hardness test. Now what is indentation? Now indentation is nothing but the phenomena where we are indenting a surface of a metal by a sharp edge material and we are applying a load. So applying the load on the sharp edge material on the surface of the metal is nothing but the indentation. Now what will happen due to that sharp edge, it will make an impression on the surface. More the impression, more the that is less the hardness and more the softness of the material. That is the basic principle of indentation hardness testing. Now we can see there are various types of testing that is available. So we can see indentation hardness is nothing but it is the resistance of material to permanent indentation under a static or a dynamic load. Most of the hardness tests operate or indentation principle. So various indentation hardness test we can see here from it. It is the first one is the Brinell test, Bayer test, Vickers test, Rockwell test, then Noob test. So these are nothing but all the tests are nothing but the indentation hardness number. Now the next type of hardness test is called as the rebound hardness test. Now what is rebound hardness test? We can see as the name itself says, something is rebounded from the something is rebounded. So what happens here? We have to in this test, what we can do, is that we have to take a surface of metal, and what we have to do, we have to drop the sharp edge indented on the surface of that material. What will happen? It will go down. Uh, it will dash the surface, and again it will rebound back. Now we have to check the height of that rebound. So if the height of rebound is more, that means more hard material is there, and if rebound height is less, the material is softer. So that is the principle of the rebound hardness test. Now we can see what is the rebound hardness test. It is nothing but the resistance offered by material to strike and absorb the energy of plastic deformation under impact load causing the hammer to rebound. Mostly the test is called as a shore scleroscope hardness testing machine. Now see next type is the scratching hardness test. Now it is nothing but it is the resistance of material to scratch by another material, for example Mohs hardness test. So in this state what will happen, the surface of metal is scratched by the another metal, harder material, which will make a scratch. If scratching is more, that means material is softer, and if scratching is less, that means material is harder. That is the principle that is used in this type of test. The next type of test is a wear or abrasion hardness test. Now it is a test, it is the resistance offered by material to abrasion or a wear when subjected to a rotational or a sliding motion. So here also the file hardness test is used. Now we can see next type of hardness is the cutting hardness test. Now it is nothing but it is the resistance of a material to various cutting and the drilling operation. The hardness is measure of a machinability of that metal. Now how the material can be cut? So resistance offered by the material to cutting is nothing but the cutting hardness test. That is the principle is used in this test. Now we see first type is the Brinell hardness testing. Now what happens here? It is a type of indentation hardness test. The scientists that have developed is called as a Dr. G.A. Brinell of Sweden. It standardized the method of quantitative determination of the indentation hardness. So this is the scientist name which have developed or which have developed the testing machine. Now we can see what he have developed. We see what is the process. Now from the formula we can see here he have developed a formula so which says that Brinell hardness number can be calculated by load applied on the surface to the area of indentation. So from here we can calculate the hardness number of the material. Now we can see here from the diagram, it is a typical type of Brinell hardness testing machine where we can see here there is a arrangement for load application when the loads are applied on the specimen. Now we can see the machine is there. It is called as anvil where the specimen is kept, and here the arrangement is such that we can there is an indenter which is sharp edge material. So what happens, we have to keep the specimen here and we have to apply the load on that. So what will happen, it will penetrate to the surface of the specimen. When the penetration is less, that means the material is harder. Then when the penetration is more, material is softer. Now there are different types of machine available. Now you can see here is a type of hydraulic type of machines where here in this machine we have to do the calculations, and this machine it shows it is an updated version where the readings are directly given on the dial. Now from various parts of the machine we can see there is a handle where load application is done, then there is a weight, then it is a anvil where specimen is kept, and this is the arrangement where the indenters are applied. Now we can say there are two types of Brinell hardness testing. First one is the standard test. Now in the what is the difference? So we can see here standard test uses 3000 kg on a 10 mm diameter ball. Now what we can see what is ball. Ball is nothing but the indenter. So this is a type of ball. So what happens here, what we can see here, in this test a specimen is taken, then we have to take the 10 mm ball, 10 mm diameter ball, and we have to apply the load on that specimen. Now what is the load here? Generally in standard test it is a 3000 kg load is applied on a 10 mm diameter ball. So that is the first type of testing, that is a standard test where 3000 kg of load is applied by using 10 mm diameter ball, or a load of 750 kg by using 5 mm diameter ball for 10 seconds when testing iron, steel and alloys. Now for non-ferrous again the 10 mm diameter ball is used and the load used is 500 kg or at least for 30 seconds, and for copper and magnesium alloys 100 kg of 1000 kg of load is used at 50 seconds and for this type of material. So that is the standard test where the loads are high and the diameter of ball is less. So that is called as a standard test. We can see the non-standard test. Now here we can see from the standard test 3000 kg or 750 kg, the loads are very high. Now in non-standard test the loads are even minimized, that is from 250 kg maximum 250 kg to 60 kg is applied. From 60 kg to 250 kg of load is applied in this non-standard testing, and the ball diameter used here is generally 2.5 mm diameter. Now you see method of testing. You see the method of testing. Now what we have to do, we have to prepare a specimen by making a flat grinding, and then it is polished so that indentation formed by loading on the surface specimen is clearly visible. Now what we can see here, whatever the specimen is there The surface of specimen should be flat and it should be polished. So why it is polished? Because we have to see the observe the indentation on that surface. So that is the first uh, process. Then depending on the diameter of a Brinell indenter, the load to be applied is selected, and maintaining the condition of the, then the specimen is placed on the anvil of the test machine, and the anvil is raised to the rotating hand wheel so that the specimen surface is brought to the tight contact with the indenter. Then depending on the material test, the time load application is set and the selected load is applied to the specimen for the present. So that is the, from the diagram we can see here. Now we can see here, this is the anvil. So under the anvil where the specimen is kept, then the anvil is raised to the tip of the indenter. Then we have to apply the load on that, depending on the load, depending on the material of the specimen, and we have to apply the load from this. Then that is the load is applied on that. So what will happen? The ball will try to indent, that means make an impression, try to penetrate on that specimen, and whatever the penetration is there, we have to calculate it. So that is the work of a specimen. Now you can see after the application of load, the specimen is released by lowering the anvil, and the specimen is ready for the measurement of the diameter of the indentation. Now what is the indentation? Whatever the impression that is made on the specimen by that ball, that we have to calculate, and we have to find out the diameter of that. Then after, from considering the value of that small indentation diameter, we can calculate the hardness number of that specimen. Now the standard formula is used for finding out the specimen or the Brinell hardness number of that specimen. Now you can see the empirical formula for the finding out the hardness number is nothing but BHN is load applied upon the area of the indentation. Then after that we can calculate now from the formula we can see here the formula BHN is nothing but the Brinell hardness testing. The Brinell's hardness number is equal to load applied upon area of indentation, and further it can be expanded. So that is a 2p upon pi d into the bracket d minus under root d square minus small d square. Now here what we can see, now here the p is equal is nothing but the load applied in kg, d capital D is the diameter of indenter, whatever the ball we are using. Now for standard we can use for standard we can use 10 mm, for non-standard we can use 2.5. Now small d is nothing but the area of indentation, whatever the indentation or the impression we are getting after a test on the surface, we can get the value of small d. So all this value we have to keep into the formula in this, and we can calculate the Brinell hardness number of that specimen. So likewise we can go for various types of material. So that is nothing but the Brinell hardness testing method. Now we can see what are the advantages. Now advantages are there relatively large size of Brinell hardness indentation. So these are various advantages. Now what we can see here, materials like cast iron or heterogeneous alloys measurement of is not only advantageous but also preferable. Then the influence of the surface scratching roughness will be less in the Brinell test. Then the surface polishing of the test piece is not needed to the larger size of Brinell indentation. So these are all the advantages. Again, there's some disadvantages are also there. No determination of entire range of hardness encoded in the commercial metals are not possible. Then due to large size of indentation, the application of that Brinell hardness is not possible on the small jobs. Then these are all the disadvantages. What we can see here, so whatever the test is there, it will make a major impression, and that is not useful. So whatever the impressions are there, so we cannot use it for the thin metal. So that is the disadvantages. Again, cracking can occur during the test. So cracking will be there on the specimen. So these are the disadvantages. So that is all the about the hardness test and the Brinell hardness testing machine. So thank you for your attention.